Prime numbers and prime factors. Prime numbers. A prime number is a number which has no other factor except itself and 1. Example, we have 2, 3, and 5. Now we'll have prime numbers beyond 5. I'll make a list of that right now. So what I want you to understand is that prime numbers are numbers in which no other value can divide these numbers except 1 and itself. So let's check out for the numbers beyond 5. So let's say 6. 6 is not a prime number because 2 and 3 can divide 6, so it's not a prime number. Let's check 7. 7 is a prime number because no other value except 1 and 7 can divide 7. So let's check 8. 8 is not a prime number because 2 and 4 can divide 8. Let's check 9. 9 is not a prime number because 3 can divide 9. Let's check 10. 10 is not also a prime number because 2 and 5 can divide 10, and even 10 can divide 10. But let's check 11. No other value except 1 and 11 can divide 11. Therefore, it is a prime number. So let's make the definition again. Prime numbers are values in which only 1 and itself can divide, which means it has no other factor except itself and 1. So if you want to write the factors of 11 now, what are the factors of 11? Is equal to what? 1 and 11. What are the factors of 13? Is equal to 1 and 13. No other value can divide 13. Therefore, it is a prime number. But for values such as 12, let's say 12, 2 can divide 12, 4 can divide 12. Okay, 3, I should have written 3 before 4. Then 6 can as well divide and 12. So this is not a prime number. Is that clear? Okay, let's go ahead. Note, odd numbers are not same with prime numbers. Some odd numbers such as 15 and 21 can be divided by other numbers aside 1 and themselves. Okay, for instance, we can have some values which are odd numbers and also prime numbers such as 7, 7, 11. Both are odd numbers and also prime numbers, but that does not simply mean that every odd number is a prime number. No. For instance, we gave 15 is an odd number but not a prime number because 5 and 3 can divide 15. 21 is an odd number but not a prime number because 3 and 7 can as well divide 21. But how about to have numbers such as 23? 23 is an odd number and also a prime number. Reason being because no other value can divide 23 without a remainder except 1 and 23, which is 1 and itself. This simply means that where odd numbers can also be prime numbers, but not every odd number is a prime number. Is that clear? Okay, thank you. Quick practice. So let's do some practice before we progress. Okay, list the first three prime numbers above 20. Okay, so the first three prime numbers above 20. 21 is not a prime number. Okay, let's just do it accordingly. So 21 is not a prime number. 22 is not a prime number because 3 can divide 21 and 7 can divide 21. 22, 2 can divide this, so it's not a prime number. 11 can as well still divide this. So we're looking for numbers in which only 1 and itself can divide. So let's check 23. 23 is a prime number because no other value can divide 23 without a remainder except 1 and 23. So let's check 24. No, it's not a prime number because 2 can divide this, 4 can as well divide this. Okay, let's check, and 8 can even as well divide. Let's check 25. 25 is not a prime number. 5 can divide. Okay, let's check 26. 26 is not a prime number. 2 can divide. Let's check 27. 27 is not a prime number because 9 can divide 27. Okay, let's check 28. 28 is not a prime number. Let's check 29. 29 is a prime number because no other value can divide 29 except 1 and 29. Okay, so we've had two prime numbers here, right? 1 and then 2. So let's check for the next one. 30 is not a prime number. Then 31. Yeah, 31 is a prime number because no other value can divide 31 except 1 and itself. That is 1 and 31. So therefore, okay, the first three prime numbers above 20 are, so we have 23, and then we'll have 29 and 31. So you can have some tasks coming in this form, so be careful to know what to do. Now I had to list this number one after the other so that I can have a clearer picture of it and know what I'm doing, taking it step by step. there is no harm in you just going ahead to write them down. But for clarity, it is always advisable you write down these maybe in your rough book or your calculation book so they can see them clearly, and then you pick the right answer. Okay, the next one says, what is the sum of the prime numbers between 30 and 40? So 30 and 40, I want to still write them out as well so I can see them clear. So 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, and 40, right? Okay, so this is where we are going to end. So this is not a prime number, so we can accept this is a prime number, not a prime number, not a prime number. 11 can divide this and 3 can divide this, not a prime number, not a prime number. 5 can divide this, not a prime number. 2 can divide this. This is a prime number, only 1, and 37 can divide 37, not a prime number, not a prime number, not a prime number. So the only values we have is what we have 31 and 37. So now you've fished them out. What's the next thing? What is the sum? So they asked for the sum of the prime numbers. So let's add them up. 31 plus 37. Okay, 1 plus 7 is 8, and then 3 plus 3 is 6. So therefore, our answer is 68, and we are done. So that's simple. So you see how identifying these values and then taking your time to bring them out makes things way easy for you. So let's go to the next one. Okay, prime factors. Prime factors are the factors of a number which does not have a factor. Nothing can divide them except 1 and themselves. Okay, so we say numbers like 5, 7, 11 are prime factors. So what I want you to do is that, okay, take this simple definition. Prime factors are the prime numbers in the factor of a number. Let me take it again. Prime factors are the prime number in the factors of a number. So let's go ahead and solve some question and you understand better. So find the prime factors of 18. So for us to find the prime factors of 18, we'll have to divide 18 using the least value that is above 1, because when you divide 18 by 1, it still gives you 18. So that's why we have to start from 2. So we have to divide 18 using the least value, and we start from 2. So let's say A is 18, right? So let's solve for that. Dividing 18 by 2, 18 divided by 2 gives us 9. 2 cannot divide 9, so we use 3. That's how. So you go to the next value because 2 cannot divide. If 2 could divide 9, we'll keep using 2. So let's use 3. 3 divided by 9 is 3. That is 9 divided by 3. So 3 can still go. 3 divided 3 here is 1. So therefore, the prime factors of 18, so prime factors of 18 is equal to 2 multiplied by 3 multiplied by 3. So I'm just taking a collection of all the values here. So up, I'm going downward. You don't mind my writing and all that, but I believe you understand. So these are the prime factors of 18. And if you check, which other value can divide 2 without a remainder? Only 1 and 2. Which other value can divide 3 without a remainder? Only 1 and 3. So there is no other value that can divide it. Unlike when we say the factors of 18. Okay, let's just do the literal factors of 18. So factors of 18, we are going to have equal to 1. If you've not checked out for the previous lesson on factors, please do, so that we don't have to keep this lesson long. 1, 2 can divide. Can 3 divide 18? Yes. 3 can divide. 6 can divide. 7, 8. Okay, 9 can divide. 9, what again can divide without a remainder? Okay, 9 all the way up to 18. Now look at this. Here you have various factors such as what? 18 is a factor of 18 but not a prime factor. 9 is a factor of 18 but not a prime factor because 3 can as well divide 9. 6 is a factor of 18 but not a prime factor. Reason being because 2 and 3 can as well divide 6. But look at 3 is a prime factor because no other value can divide except what? Except 2 and 1. And when we're talking about prime factors, usually we don't start from 1. So 1 is the factor of every number but not the prime factor of a number. Is that clear? Okay, so having said that, we now know that 1 is the factor of every number but not the prime factor of every number. Okay, 42. So for 42, starting from 2 again, 42 is, so 42 divided by 2 gives us 21. Can 2 still divide? No. So we'll go to the next number. So 3 divided 21 is 7. And then we'll use 7 right now. So 7 divided by 7 is 1. So therefore, the prime factor of 42, so P of 42, so that's prime factor is equal to 2 times 3 times 7. And if you can, as you can see, no other value can divide 2 except 2 and itself. No other value can divide 3 except 3 and itself. And no other value can divide 7 except 7 and itself. So let's solve for 55. So for 55, 2 cannot divide 55, so we can't start from 2. 3 cannot as well work, so we'll start from 5. 5 here is 11, and nothing can divide 11 except 11, so 11 here is just 1. So therefore, prime factor P of 55 is equal to 5 times 11. Okay, so sometimes this question can come in the form, they can tell you write 144 as the product of its prime factor. So sometimes that's how they put this kind of question. So let's do that. So we'll say 144. Okay, let's start from 2. 2 can divide 2 into 144. 2 here is 7, and 2 here is 2. So 72. 2 can as well still divide 2 here. 2 here, 2 into this is giving us 36, right? Then 2 here, 2 can as well work. 2 here is 18, right? Okay, 2 can still go. Wow, we have a whole lot of 2 coming in. So 2 here again is giving us 9. Oh, 2 cannot go again, so we use 3. 3 here is 3, and 3 here, 3 divided by 3 is 1. So therefore, prime factor P of 144 is equal to, so we're taking all the values here, and then we are going to write them. So we have 2 times 2 times 2 times 2, 1, 2, 3, 4 times 3 times 3. And that's just it. So these are the prime factors of 144, and there is no other value that can divide this value except 1 and themselves. Having said that, we've come to the end of the lesson. Please do well to like, comment, and subscribe. Check out for the previous lesson on factors. It is very, very fundamental to this. So before you come to prime factors, you have to be able to understand what are factors. Having said that, thank you.